Let me introduce myself. My name is Mariano Martínez Peck. I'm from Argentina. So you may know that my native language is Spanish, and I will do my best to speak in English. If you don't understand something, feel free to ask. There's no problem. What I'm going to talk is about a project we did. It's called SqueakDBX, which is the complete and open source solution to relational database access. And what does it mean? It's marketing. This is not really so true, but you will see that we have done a couple of things. The typical question, this is the team that they couldn't come, so I promised them to put the picture of them. From right to left, it's Hernán Casinelli, Germán Palacios, Esteban Lorenzano, and me. This picture was taken in small company's office where we usually meet and work for the project. The typical questions, we are friends, very good friends. We met at the university and then we work together, so we live near, so we really work in groups. The project began as an Esteban Lorenzano's idea because he was trying to use Squeak and Pharo for commercial applications, for enterprise applications, and he found a barrier and restrictions with the relational access, and thus we decided that this project could be useful for people. And then, okay, we used that project for our final signature at the university, so it's like something like a thesis. And what is SqueakDBX? It is a relational database driver that lets you communicate with measure of the databases. Not only the open source ones, but also the proprietary ones. To do that, our driver delegates to an external library written in C, which is called OpenDBX, which gives us a common API to talk with the different databases. But with this explanation, you still don't understand why we say it was the complete solution, because that is just the part of being a driver. But the thing is that we are also working in a blurb, which is an object relational mapper for Smalltalk, and thus if we integrate blurb with SqueakDBX, we are able to map objects to tables and all of that stuff with most of the databases. I beg you don't discuss about object-oriented databases versus relational databases. This is off topic from my talk. You are always discussing that. You may have an opinion, and that's all. The only thing I would say is that sometimes, because we want or because the client makes us, we have and we use relational database. That's all. Anyway, we rather program in object and use a relational database than having to move to another technology like Java and have to use a relational database. For our signature, last year we did a survey in Argentina. All the interviewed people were technical. They were programmers, technical leaders, analytics. We asked two simple questions. The first question was how many times they were forced to use a particular database. And this is the result. It's a bit complicated, but I will explain you there. It means that the 24% of the people were forced 10 times of 10 to use that database, a particular database. The 30% of the people, like 7.5 times of 10. And only 3% of the people were always free to choose which database or which percentage strategy to use for an application. So what this shows is that in normal companies application or enterprise application, there are few times where we can really choose how to persist our objects. Mostly the client make us use a particular database. And the second question was which databases. The first one was Oracle with 30% of the database, then SQL Server, then MySQL, DB2, Postgres, and whatever. Until here, there is nothing weird with the results we get, but now let's see the current Squeak situation. The current situation is this. First, there are only native drivers for MySQL or Postgres. Yeah? There is an OODBC driver, but it's quite limited. Sorry. Why? There are a couple of reasons, but for example, you have to configure the ODBC from outside the system. The ODBC Squeak driver locks the virtual machine for a long time, as I will show you then, so it's not very performant for a website. It is not proprietary, it doesn't work really good in different operation systems. I know in Windows, but I think it works in Linux, but a bit tricky. And thus we do not consider this as a solution. And the third thing is that Blurb, the project, the ORM, works for the different Smalltalk dialects. But the port of Blurb to Squeak, it is completely hard-coded to the Postgres native driver. So if you want to use Blurb in Squeak, you have to use Postgres. There is no other way. So if we compare what we get from the survey with the current situation, you will probably notice that we are in trouble. And why is this? Big trouble. Why? Because if we want to write SQL by hand, no mapper, we can only achieve the 20% of the project, which are MySQL, Post, plus Postgres. That means the native driver we have. And if you want to use Blurb, which, I mean, nobody wants to write SQL by hand nowadays, programmers are much lazier when the history, I don't know how to say it, doesn't matter. And if you want to use Blurb, we can only achieve the 8% of the project, which are the ones that are with Progress. So, this is why we did SqueakDBX. I remember something to say. When we did SqueakDBX, we started 2 years ago. We were not aware of Pharo. I even know if Pharo was started 2 years ago, but it was called SqueakDBX. It's called SqueakDBX now, but it supports Pharo, and I guess it supports Brest or whatever Squeak fork. However, our team is developing with Pharo since a couple of months. So, which is our goal? It's very easy. We want to be able to achieve all of the project when writing the SQL by hand, but also those projects where we can use an object related mapper like Blurb. So that's our goal. Our purpose. This is one driver to rule them all. I mean, the same piece of code, the same driver to communicate with all of the databases. You don't have one driver per database, but one that lets you communicate with all of them. Something like the Lord of the Ring, and you know. Okay. To understand the SqueakDBX architecture, I think we should first understand the OpenDBX architecture, which is the library I told you that we use from the Squeak side. So, suppose there are a lot of databases like Oracle, MySQL, Postgres, Sqlite, whatever. Every database has an interface to communicate to it through a C library. Yeah, because the vendor doesn't provide us with Smalltalk drivers, but all of them has a C driver, which is usually known as the client library. But the problem is, if you see, for example, Oracle uses the OC header, the libc-lntsh library. It has n number of functions. The functions are called like this, and it has some parameters and some data structures and whatever. If we see the MySQL client library, it's totally different. It uses another header with another library, with another a different number of functions, with different names, different parameters, all different. So, in summary, all of the databases has a client library to talk to it, but the problem is that all of them are different. So, here is where OpenDBX appears, and it gave us, as the user of the OpenDBX, a common API to talk. So you talk to OpenDBX in the same way to all of the databases, and it will know how to map that with the client library in particular. Why we choose SqueakDBX? Because it's powerful. We did a little of research trying to see different alternatives, but we found OpenDBX was the best. In summary, it is fast. It is even as fast as the client library, because in contrary as the OODBC driver, for example, it doesn't try to unify the SQL, but on the other hand, it tries to favor the speed and being flexible. So it is fast. You can see the benchmarks on the web page. It's even the same as the client library. Simple to use, it's flexible, it's very easy to add new backends to support. It's cross-platform, it compiles in Linux and Macintosh, and it also compiles in Windows using MySQL or Cygwin, if you know what it is, but doesn't matter. It works. It uses asynchronous queries. This is extremely important for us, as we will see later. You can take advantage of the feature of the data of a database. That's something you cannot do through OODBC. And finally, it has good documentation and mailing list, and the people are very helpful. If you see a deployment infrastructure, you see you have two PCs. The one where we have the Squeak image, and perhaps the database is in another PC, but it does a GTIL. So if we have our image, and we have SqueakDBX there, SqueakDBX will talk to the OpenDBX library, which is in the same PC, and the OpenDBX library will talk to the database, in particular, client library. So, if you don't know that SqueakDBX is from a cube source and run the test, it would fail. Why? Because you need to have OpenDBX library installed in your PC, and you also have you need the client library. With OODBC, you don't are aware of this because it's already installed in Windows. But and then the client library will talk to the database. The client library is the one which opens a socket and implements the protocol to the database. Now I'm interested in showing you how the communication between the Squeak image and the OpenDBX is. So, in one side we have our Squeak image there are a lot of objects alive and happy, and they send messages to each other. But on the dark side of the moon we have functions with structures, and they are not, C. So there must be a connector here from the Smalltalk to the C library. Here we use the most common solution for Squeak, which is the foreign function interface, which is the FFI. But the FFI has a big problem, big problem for us, which is that it locks the entire VM and the function returns. If you send that, let's see an example. Let's see how the Squeak ODBC driver works, so that then we compare it. Suppose this is the Squeak ODBC driver, this is the ODBC library in itself, and this is the database. if you, from Smalltalk, using a message to do a query to the Squeak ODBC driver, it will delegate to the ODBC library, but it will return here, yeah, until the whole query is processed and returned. Yeah? So if there comes another query, suppose from another request, if we have a web application, it's very common, we have a lot of requests with a lot of people connected, and suppose there comes a second request, he will be like this, waiting that the other query finish. So the time the virtual machine is locked here is all of the time of the query. And that's what I told you about FFI. FFI locks the whole VM until the function you invoke returns. Yeah? Now, the solution we did for this problem, that it was the biggest problem we found, is use the feature SqueakDBX has, that is asynchronous queries. So, with this we get minimal virtual machine logs, and we retry until the query is finished. Let's see an example of how SqueakDBX works in this case. We have, as in the other case, the SqueakDBX driver, the OpenDBX library, the client library of the particular database, and the database. When we send a query, OpenDBX immediately returns us. Yeah? And he will then send the query to the client library and do all the other stuff. But here, the return to the Squeak side is very fast. You don't have to wait until the query is done. So then we can wait for a timeout. This was the first version, but then we did another thing now, because you have to wait and then ask OpenDBX, is it ready? No. Is it ready? No. Is it ready? Yeah. Okay. Yeah. There's no way OpenDBX can let me know that it is finished, so I have to ask. So what I did is, if I have to wait, what I do is do a yell over the scheduler so that it can take another request if they are in the queue. Yeah. So queue. So if so I told you about my English. So if another query comes later from another thread, from another client connected to a website, suppose, it will be attended because the virtual machine is not blocked. So we have a lot of requests sending queries to the database. We are able to manage all of them with this approach. So the time the virtual machine is locked here is very little in comparison with the other approach. You see? It's immediately. We don't have to wait until the query is done. Now this is one of the most important features we have in compared to the other alternatives in Squeak. Well, and if it's ready, I just obtain the results. Now I will go fast with this slide, but the idea is because everybody would like to do a Smalltalk driver instead of having to delegate to an external library and all of that. But there are a bit of problems. For example, if I want to do a Smalltalk driver, I have to do one per database. In our case, it's just one driver to all of the databases. As a side effect of this, it's a lot of time if we have to do a driver per database. I don't know if the driver is completely implemented in Smalltalk, I don't know, but perhaps there are performance issues, the things that I really don't know. But, and this is the most important, you're going to do a Smalltalk driver for proprietary databases, because the vendor doesn't make public the protocol. So you cannot open a socket and implement that protocol because it is not public. So for proprietary databases, the only way is to use a driver they gave you, and they don't give you Smalltalk driver. They give you C Java, and perhaps Python or any other thing. So we can, SqueakDBX works with both of them. When, on the contrary, it's difficult to debug because you have C on the other side, and if it's all Smalltalk, it's easier. We are platform dependent because you need the library installed in your PC and perhaps compiling, and in the other solution you don't need nothing. And the thing about that I told you about the logs of the F.A.Q, but we have a solution for this. And as I told you, this is the most important, and no matter which one is better, for proprietary databases there is no other way that delegating to an external library. Now, a bit of the design, we have a couple of layers. The first one is the structure, where you have classes like connection, result set. This is the final API for the user. The user will use these classes. He can even be not aware of OpenDBX. It's completely independent. The platform layer, it's dependent of OpenDBX. Then we have the connector. Oops. Then we have the connector. Then the connector would use a particular connector. For example, we use F.A.Q, and F.A.Q then would talk to the OpenDBX. And now here we are going to see a little demo because I have not too much time. But I show you. Did you see well the code from here? Okay. This is a simple example of what you do. You first must instantiate RDBMS connection settings that you have to put a host, or IP, a port, a database, and username and password. Then you must instantiate a connection, and you have to tell her which platform do you want to use. As you may imagine, there are a platform per particular database. There is an abstract platform and then one per platform. And you send the connection settings, and then you have to do a connect. It will open a TCP connection to that port and IP. And then you can use the connect, which it will log you in the database. It will use the username and the password and the database, and will open a real connection to the database. You can use the same. There is a message that it is connect and open, yeah. But we won't use this because something that I will explain to you later. Then we can just execute. We have the execute message, and we send the query we want to execute. We can have parameters here. We thought to have a SQL query builder, but right now we don't think it's necessary. If you see here all of this type of queries like delete, update, or insert, then it will return a class which is the DBX result, which the result that you can ask, for example, the rows affected. That is the most important thing you may ask to a return of that type of query. Then you can start the transaction. If you want to manage transaction, you can use that. Execute, then you can commit, and then you must close the connection and finally disconnect. This message can be not necessary in most of the cases, because the disconnect, if it finds that it is open, it will do a close first. And if you open a DBX connection, but you do not call neither close or disconnect, when the garbage collect an instance of a DBX connection, it will automatically disconnect it. That's to the aim to not let open connection to the database. So if we run this test, I have running locally a Postgres database. So you can see it may work because this constraints. Yeah. Give me a second, please. I will remove the tables and all that because sometimes. Let's see. Again. Yeah, it was a matter of I have already some pressure. And the important is that this piece of code, if I only change the port, for example, to connect to an Oracle, I put this port. The database is XA because I use the Express edition, and I change here the platform for an Oracle one. And I save it here, and I run it. It should again work. Yeah. So the important thing is that the same driver, the same piece of code, works with most of the databases. I could test another database, but I think it's enough. The only thing you must care is that there is no SQL conversion in OpenDBX. There is nothing unified. You must write the SQL so that the database understands it. There is no conversion. But this let you use particular features of particular databases that they are not part of the standard of the SQL, but you can take advantage of that and use it. So, if you write a complete application with SqueakDBX and you want to change the database, it will work if the queries are understood by the backend. But the driver, the messaging, and the way to use it is the same. And I have a little other example. This is Linux, but I have a Windows virtual machine here. Believe me, Windows. Yeah. And I have the same test I have Progress running locally also in running Progress locally. That's why I came earlier here, because my machine takes like 15 minutes to start and Windows takes 10 more, and I have to be 20 minutes earlier. So if I run this test in Windows, it will also work. I'm sorry, I have not a Mac to test. But if you want to give me one, okay.
Everything is possible.
Oh, who can use SqueakDBX? Easy. Everyone. Everyone can use it. I think what's your son, Steph? Seriously, our main target is to be the driver, the layer which is above of all the others. I mean, we are the driver. So the idea is that someone can build things on top of us, and all of that stuff they do, sorry, it can be used to most of the databases. But there are already people who did it. So who can use an application? If you just write SQL by hand, you can use SqueakDBX directly. It can be used by Glor, as I will show you later. Magritte, RDB, which is a project that uses Magritte and uses the descriptions of Magritte to persist it in a relational database. SqueakSave, I don't know if you saw the presentation the other day, but it's a project that it also maps you from object to database to tables. And it's like a mapper. Like it's more like active record than log. But I sent some emails to the guy who is developing it, and he wants to do a SqueakDBX driver because he was having problems with having to deal with different drivers. So this is another one you can use. Mo, I don't know but perhaps in a moment he wants to use SqueakDBX and any others. This is our current status. We have MySQL. As you can see, the only problem we have is here. We need a master in a guru in C and Windows linking because I don't know what is happening. But today, yeah, it's funny because today I received an email from the OpenDBX mailing list from the author who says that it did a release today and it is working. But I couldn't test it, so now I tell you it doesn't work. SQL Server, nobody tested in Mac, so I don't know. But all of the other works. And work okay. I mean, we have 100 of tests, and they are all green with all of that combinations. However, the important thing here is that OpenDBX supports more backends than these ones. For example, it supports Fiverr or Sybase or Informix, but we didn't have time yet to install it. Imagine if I have to install 3 more databases in my machine, I think I would. So if someone tested with one of the databases that is supported by OpenDBX and it's not here, let me know and I add it. Okay. Everybody likes numbers, so we have a lot of benchmarks, a lot of them. I just put 2 here because I haven't all of the time. But we have teeny benchmarks, which are little selects until just 10,000 insert or select, and then we have the big benchmarks, which are run several threads at the same time doing a lot of queries. But these are the simplest one. We did a benchmark for progress, for example, and you can see SqueakDBX is the blue one, and the native driver is the red one. So these are the tests we do. This is an insert. This is a converted insert because it means that you have objects and you have to embed them, you convert them and put it in a query, and it takes a bit more. A select from 100 register and a select of 1,000.
The driver is one that is written in Smalltalk.
Yeah. Sorry, yeah. The native driver, is the one that is written in Smalltalk. And the blue, okay, it's us. Another benchmark for MySQL, for example. This is more similar, but when we did the big benchmarks, there was a bigger difference. I even could put it in the same graph, no, in the same chart, because it was too big and I couldn't put it in the slide, so I removed it. Okay, this is a boring slide, but I think it's important. The features we have, it's as I show you, the logs in the virtual machine is little. We have developed our own Squeak VM plugin, so that to replace FFI for this, but Esteban Lorenzano did it, and it was only tested in Mac. I don't know if it works in Windows or Linux, and it's yet in development. It's even in beta. So, but the idea is to, if this plugin doesn't lock the virtual machine, we probably replace FFI for this plugin. But it is in development yet. We have automatic fields conversion. That is when you send a query to a database, you have the SQL types like char or date or timestamp or whatever, and we automatically convert those fields to Squeak objects. So if, for example, you retrieve a row which has a char, you will get a string object, and date and a date. And it's flexible if you want to change that mapping. You can configure enable or disable logging. This is important because, as I told you, are able to use the particular features of the database. For example, if you want to use encryption, compression of the network traffic, multi-statements, special results, all of that stuff that perhaps one database supports and another one doesn't, this is allowed. And you remember I told you that we recommend to send the message connect and then the open instead of connect and open. This is because here, let's see if I have an example, because most of those features have to be enabled after the connect but before the open. That's the protocol. So if we see example, for example, those are all the tests we have. And if you see, for example, the encryption test, oh, this is commented.
That's why it's wrong.
I don't know. Compression? Yeah, the compression, for example. You have to do the connect, then you have to enable the compression, and this will return you if you can enable it or not. So if the result is true, you automatically can the database will compress the queries, and if don't, you won't be able. So it's like you must to ask if it is supported, and if it's true, you can use it. So the special feature, if the client bought Oracle and spent thousands and thousands and millions of dollars, perhaps he will want to use the features it has. So with this, it is. Ah, sorry, I forgot to put my slide. Oh, it was in Windows. Okay, the last thing, the multi-statements, we can, it's like another special option. You can use multi-statement if the backend lets you, but the important thing of multi-statement is for the store procedures and the functions, because they are managed in a similar way. Finally, I told you this, that the garbage collect will disconnect you. What we did, we have enough unit tests. There are like 100 that they are running. Acceptable test coverage, we don't have 90% of test coverage. I think we have 60 or 65. But there are a lot of methods we should exclude from the test coverage tool, but we didn't have time to do it. But it will increase a percentage. We run the small runs when we do a release. We first run all of the rules so that to detect special bugs or those bad smells. Good enough design. We had big changes, and the design was very good for those changes we have, and we are proud of that. For example, SqueakDBX, OpenDBX only work in Linux, like 1 year ago. I started to play with MySQL until I make it work. And when I make it work OpenDBX in Windows, we just subclass a class and adapt it, and it worked. I mean, and there were other big changes, and the little was small. The GLORP integration, I think this is really important. The documentation we have created just yesterday. Our website. Now we have the wiki, but it's my feeling that wiki is a bit, I don't want to say ugly, old, because it's like 20 years ago, and I don't like it. So we are creating our own website with Pierre and Cesar, but we are waiting the domain registration of SqueakDBX.org. So that's temporarily where the web page is. The code is very well documented. You will see that all of the methods have a description of what they do. We have our own mailing list. there are few traffic, there are I think 20 people registered, or yeah, 20 and very little, but we are starting. The benchmarks I told you. This is the future work. Complete the cloud refactor and iteration. More backends in more operation system. This will be on demand. When someone needs it, we will do it. But right now, we won't spend time on that. Large object support. Right now, we do not support blob or all of that large fields. Better store procedures and function support. Continue with our plugin, which is yet in development, and try Alien FFI to see if we can get a better performance than now. On Monday I'll talk with Jan. We are trying, he and we are trying to do a port to Smalltalk-X. We will be working on that also. And the last thing is the global progress. This year we were sponsored by Smalltalk. The main goal for this year is to terminate the Glorp integration. So this is what we have done until now. We made Glorp to work on Pharo. We did the refactor so that now the Glorp is not hard-coded with the Smalltalk progress driver, and we did a driver for SqueakDBX. I will show you very fast. This is Glorp, where you have a database accessor which is abstract, and then you have a subclass per Smalltalk dialect. So this is the Squeak database accessor. This is before our changes, and this accessor was completely hard-coded. It uses directly the PG connection, which is the class of the Smalltalk driver for progress. So what we did is this. We put an abstract database driver so that the Squeak database talk to it in a unified way, if you want to say. And then we subclass it, and we implement particular driver. We did one for the progress Smalltalk driver, that we put there all the stuff we remove from the Squeak database cursor. We did our SqueakDBX driver, but it only works for Progress and Oracle right now, but the idea is to continue. That's all I want to win. Thanks to Norbert Sandusky, which is the OpenDBX author. He was really helpful with us. To Valentine with the Glorp decisions and changes. To Stefan Dugas and Trisou for sponsoring us not only last year but also this year again, for letting us expose our project here in ESUG. So we really want to thank him about that. That's all. If anyone has any questions. Question? No? Perfect.
Sorry, one question. Is it possible to have multiple images access the same database? And are there any concurrency checks, things like that?
If I can have multiple images accessing to the same database, yeah, there will be no problem because it happens from outside, I think. I mean, it's not... it's like two people... OpenDBX, it's a shared library and it's managed by the operation system. So it's the same as if I have running OpenDBX from... So it's, several times I have OpenDBX running from a command line with a program in C which use it, and at the same time I can have my image running. They both will use the same shared library, but that the operation system handles that. So I didn't really test it, but I think it should work.
Would you get a status back at the Smalltalk level if there was a lock or contention problem?
Sorry,
Would you get a status back if there was a database error or a log?
Yeah. We have an error handling. OpenDBX returns us like a number. For example, it returns -1 if there was an error, but there is another function to obtain the description of that error. We handle all of that, and we write an OpenDBX exception or SqueakDBX exception, where the description of the exception is the description we got from OpenDBX. So yeah, there is a good error handling in that way. Okay.